Have you ever just, stopped and thought about the sheer complexity behind the apps you use every single day? Like, think about your streaming service, how it magically knows what you want to watch next, or those huge online stores, handling millions of people buying things all at once. How do companies build something that big, that complicated, and keep it running smoothly, and not just running, but constantly improving, adding features almost instantly?
It's a really good question, and honestly, it's a massive engineering challenge because what feels seamless to you as a user, that's built on some incredibly sophisticated thinking underneath. The old way, having one giant piece of software trying to do absolutely everything, that's pretty much gone for these big players.
Right, and that's exactly why we're doing this deep dive today. We're looking at service design in microservices.
Hmm.
It sounds technical, maybe, but it's really fundamental to how these modern adaptable systems get built. Our mission here is to take a foundational guide. It's called Service Design in Microservices, a beginner's guide, and really pull out the core ideas for you. We want to give you a clear sense of what this actually is, why it's so important now, and, how it's done without getting totally bogged down in jargon.
Exactly. We're going to unpack the really essential bits from our source today, focusing on what service design actually means, what the key principles are, and also some of the critical things you have to consider to make it work effectively. You'll get a sense of how giants like Spotify, Amazon, Netflix, how they approach their architecture using these ideas.
Okay, so let's start there. When we say service design in microservices, what are we really talking about? Like, what's the core concept?
Well, at its heart, it's really about planning. It's the process of planning and structuring your software, but not as one big block. Instead, you break it down into these small, independent components. We just call them services. Each one is designed very specifically to handle one particular task within the bigger application.
Yeah, one specific task.
Right. And the real power comes when these individual services work together. They collaborate to deliver the full experience, like the online store or the streaming platform you use.
That feels like a really different way of thinking compared to maybe how software was built, say, 15, 20 years ago.
Oh, completely different. Yeah. Our source actually uses a pretty helpful analogy. Think about setting up a busy cafe. You wouldn't hire one person and expect them to do everything right. Bake the bread, cook the meals, make the coffee, run the till.
No, that would be chaos.
Exactly. You'd have specialists, a baker, a chef, a barista. Each person has a really clear role. Service design is like planning that team, defining who does what their responsibilities are, and crucially, how they need to coordinate so the whole cafe runs smoothly for the customer.
That cafe analogy really helps visualize it. But what's the trickiest part when you translate that idea into software? Where do things often go wrong when defining those roles, those services?
That's a good point. The challenge is often finding the right balance. It involves a few key steps. First, you've got to define the purpose of each service very precisely. Like, this service only handles user logins, that one only processes payments, clear lines. Second, you need to figure out how these services are going to communicate with each other because they're independent, but they're definitely not isolated. They need to talk. And third, you have to make sure that even though they're independent, they can work together seamlessly without tripping over each other, the pitfalls. Often it's making services too big, they start becoming mini monoliths again. Or the opposite problem, making them too small, too granular, and you end up with this incredibly complex web of tiny things constantly chatting, which creates its own problems.
Okay, so getting that balance right. Why is that so critical for modern apps? What's the big payoff?
It's crucial because good service design makes these microservices, well, efficient, obviously, but also scalable, and maybe most importantly, resilient and adaptable. By breaking down the complexity, you drastically reduce the risk of one problem causing a total system meltdown. Fewer cascading failures, fewer delays, fewer errors overall. It just leads to a much more reliable and responsive app for you, the user.
Right.
Think about Spotify again. They have distinct services, right? One for playing music, one for managing your playlist, another for recommending new songs. Each of those is designed to do its job really well and interact cleanly with the others. That's why, your music probably keeps playing even if they're busy updating the recommendation engine behind the scenes.
That makes sense. So, okay, you decide to break things down. But how do you stop it from just becoming, well, a mess? There must be some rules, some guiding principles for actually designing these services effectively.
Oh, absolutely. You can't just randomly chop things up. There are some core principles that really guide this whole process. They ensure the services are well structured, effective, and not just a jumble of code. The first big one is called the single responsibility principle, SRP for short.
Okay, single responsibility.
Yeah. And it basically dictates that each service should have one clear job. Just one. So, for example, you might have a service dedicated only to handling product searches in an online store, and a totally separate one that only handles user authentication.
So one job, one service. What's the real benefit of being that focused? Does it make teams work better or something?
It absolutely does. Think about it. If a service has only one responsibility, a small team can become true experts on that one thing. They can understand it deeply, they can innovate on it, they can update it, deploy changes really quickly, and crucially, they can do it without this constant fear of accidentally breaking something totally unrelated somewhere else in the system.
Ah, okay. Less risk.
Way less risk. Imagine if Amazon's checkout service also managed, I don't know, product descriptions. Every time they tweaked the payment flow, they'd have to worry about messing up how products look on the page. SRP avoids that. It makes evolution much safer and faster.
Got it. But if they're all separate, how do they actually work together without becoming completely dependent on each other's internal details? That sounds like it could get messy fast.
Yeah, and that leads straight into the next principle, loose coupling. This means services should be designed to be as independent as possible. They should rely on each other as little as possible, especially on the internal workings of other services.
So they interact, but they don't need to know the nitty-gritty of how the other one does its job.
Exactly. If services are tightly coupled, a change in one service can have this ripple effect, potentially breaking others. It's like a chain reaction. But with loose coupling, you can make changes, maybe even completely replace the implementation of one service, and as long as you maintain the agreed upon way of communicating, the other services shouldn't even notice.
Like your Netflix example, they update the recommendations, but my movie keeps playing smoothly.
Precisely that. The streaming service doesn't need to know how the recommendation service comes up with suggestions. It just needs to know how to ask for them and what format the answer will be in. That's loose coupling in action. Then there's domain-driven design, or DDD.
No name-driven design? Okay.
This principle is about aligning your services with specific areas of the business. We call these domains. Think about the natural divisions within a business, like ordering, or inventory management, or customer support.
So the software structure actually mirrors the business structure.
Yeah.
That seems smart.
It's very strategic, yeah.
Yeah.
It helps ensure the software design directly supports how the business actually operates and thinks about itself. It makes communication between technical teams and business stakeholders much easier because they're speaking the same language, talking about the same concepts. So an e-commerce app might have an inventory service that only cares about stock levels, and a separate orders service that only cares about managing customer purchases. It maps directly to the business reality.
Okay, that makes a lot of sense. But with all these independent parts doing their own thing based on business domains, how do you make sure they don't accidentally start doing the same job or get confused about who's responsible for what? Seems like you'd need really clear lines.
You absolutely do. And that brings us to the need for clear boundaries. You have to be really explicit about defining what each service is responsible for, and just as importantly, where its responsibilities end. This is critical to avoid overlap, stop confusion, and prevent scenarios where, say, two different services are trying to update the same piece of customer data. That leads to chaos. Think about Uber, the service that matches riders with drivers. It doesn't handle payments. There's a completely separate payment service. That clear boundary, that separation of duties, ensures each part works efficiently without interfering with the other.
Makes sense. And how do they actually talk? You mentioned communication earlier. Is there a standard way?
Ideally, yes. That's the principle of standardized communication. Since these services need to interact, often over a network, they should use consistent, well-defined methods. Usually, this means using APIs, application programming interfaces. Think of APIs as contracts that define how services request information or actions from each other.
So like a common language they all agree to speak.
Exactly. It's a common language, a standard protocol. This ensures that interactions are reliable, predictable, and don't break every time someone changes something minor internally. Look at Twitter, or X. They're different services, posting tweets, handling notifications, managing user profiles. They all use standardized APIs to share data and coordinate actions smoothly. What's really powerful here is seeing how all these principles, SRP, loose coupling, DDD, clear boundaries, standardized communication, they all work together. Collectively, they create a system that's robust, much more resilient to failure, and incredibly adaptable to change, which ultimately makes the application better for you and easier for the company to manage and scale.
Okay, that paints a really clear picture of the why and the what, the core principles. But let's get practical. For someone actually trying to implement this, what are the big hurdles, the common pitfalls they need to watch out for?
Right, this is where the rubber meets the road, and yeah, there are definitely some tricky aspects to navigate. One of the very first things you wrestle with is defining service size and scope. We touched on this, but it's worth digging into. Services shouldn't be too big, right? You don't want them turning into these mini monoliths that handle too many unrelated tasks. But equally, they shouldn't be too small. If you break things down too finely, you can end up with what's sometimes called nano services, and that introduces just massive complexity in terms of communication overhead and managing all these tiny pieces.
So there's a Goldilocks zone. Not too big, not too small.
Exactly. Finding that just right sweet spot is key. It's more art than exact science sometimes. For example, a service that tries to handle both user profiles and payment processing, probably too broad, too many different concerns. But splitting out every single tiny validation rule, like checking if an email address looks valid, into its own separate service, that's likely going too far, creating unnecessary network calls and deployment headaches. You look at companies like Etsy, they tend to design services around core business capabilities like product listings or the checkout flow, focused but not excessively fragmented.
Okay, finding that balance is crucial. Now, you mentioned services managing their own stuff to stay independent, but if the order service has order data and the customer service has customer data, how do you keep things consistent? Like, what if a customer changes their address? How does the order service find out? That sounds like a potential nightmare for data consistency.
It is a significant challenge, absolutely, and it brings us squarely to data management. The principle is often that each service owns its own data to maintain that loose coupling. But you're right, that makes keeping data consistent across the entire system tricky. You can't just have services constantly querying each other's databases. That creates tight coupling again. So the common solution involves strategies like event-driven architecture.
Okay, so one service announces something happened.
Precisely. When something important changes, like a user updating their profile in the profile service, that service sends out an event, basically a notification saying, hey, this happened. Other services that care about that change, like maybe the shipping service, can listen for that event and update their own local copy of the relevant data accordingly. Think about Uber again. When the payment service successfully processes your fare, it might publish a payment complete event. The ride service listens for that, sees it, and then updates the ride status to completed. The data becomes what we call eventually consistent. It might take a fraction of a second, but it gets there without the services being directly tied together.
Okay, eventually consistent. That makes sense. But all this communication services talking, sending events, that's all happening over a network, right? Which isn't always reliable. Couldn't that lead to delays or things getting lost?
It's a very real concern, and performance is definitely a major consideration. That's communication and performance. You're absolutely right. Relying on network communication inherently introduces latency delays. And networks can be unreliable. Requests can fail. So designing for this is critical. You need efficient APIs, yes, but you also often need more robust mechanisms like message queues or event streaming platforms. These tools can act as buffers, holding messages if a receiving service is temporarily down, and ensuring reliable delivery even with network hiccups. Netflix is a great example here. They invest heavily in incredibly robust and optimized APIs and sophisticated communication infrastructure, precisely to make sure that communication between, say, the service that finds your movie and the service that actually streams it happens super smoothly and reliably, minimizing that lag you might otherwise feel.
Right, minimizing lag is key for user experience.
Right.
What about when things do go wrong? Or just keeping track of everything? With potentially hundreds of services, how do you even know if everything's working correctly?
That's a huge operational challenge, and it leads us to testing and monitoring. Testing a distributed system of microservices is inherently more complex than testing one single application. You don't just test each service in isolation, you have to test the interactions between them. And monitoring becomes absolutely essential. You need tools, good observability tools that can track the health, performance, and error rates of each individual service. But you also need ways to trace requests as they flow across multiple services, so if something slows down or fails, you can pinpoint where the bottleneck or error occurred in that chain. Spotify, for instance, puts a lot of effort into monitoring. They constantly watch their playlist services, their streaming services, their discovery services, so they can detect problems, often automatically, and fix them fast sometimes before users even notice anything is amiss.
So it sounds like it's not just a technical architecture shift. It demands a shift in how teams work, too.
Oh, absolutely. That's a critical piece that sometimes gets overlooked. Team alignment and skills. Microservices work best when you have small, autonomous teams that take full ownership of one or a small number of services. They build it, they run it, they own it end to end. But this requires really effective collaboration between teams because their services depend on each other. And the teams themselves need the right skills, not just in coding, but in managing distributed systems, in understanding monitoring, deployment pipelines, all that operational stuff. You need to ensure teams really understand their services' role in the bigger picture, have the right tools, and crucially, get the training needed to work effectively in this kind of environment. Amazon is famous for this, right? Their two pizza teams model, where small teams have full ownership of specific services like product search or the shopping cart. This fosters deep expertise and clear accountability. It's an organizational shift that has to go hand in hand with the technical one.
Wow. Okay, so pulling this all together, service design in microservices, it's really about creating these focused, independent services that mirror business needs. And it sounds like success hinges on rigorously applying those principles. Single responsibility, loose coupling, domain-driven design, and then proactively tackling the practical challenges, figuring out the right service size, managing data consistency with things like events, ensuring reliable communication, and having solid testing and monitoring. It's clear how companies like Netflix, Uber, Amazon manage to build these massive, resilient systems that power so much of what we do online. It's not magic, it's, well, meticulous planning, the right architectural choices, and the tools to manage that complexity.
Exactly. It represents a fundamental shift, really, moving away from rigid, monolithic structures towards these more fluid, adaptable, evolving ecosystems of services. It's a different way of thinking about building and maintaining software.
So here's something to think about. Given how much careful design goes into these distributed technical systems, with teams taking ownership of specific autonomous functions, how might our traditional ideas about teams and collaboration need to change? Not just in software, but maybe for any really complex project to succeed in the future. Something to mull over, perhaps? We'll leave you with that thought until our next deep dive.